Chapter 4, Section 5, we are proving triangles are congruent. And I'm going to write here the 5 different things we can use. We can use side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. Those are the 5 ways we can prove triangles are congruent. In our first proof, we are given that BC is parallel to AD. And whenever you hear parallel lines, you should think something about some angles being congruent. And also BC is congruent to AD. Whoops, how about that goes right here? BC is congruent to AD. That is our given. Well, with the parallel lines, we can say something about some angles. And I'm going to put a 1 right here and a 2 right there. Angle 1 is congruent to angle 2 because we have parallel lines, alternate interior angles. So I'm going to mark those 2 congruent. And then BD is congruent to BD by the reflexive property. And you're going to use that a lot. And that tells us that that bottom part of that triangle is congruent to the top part of this triangle. And now, if we look at our combination of sides and angles, you have side, angle, side. So we can say triangle ABD is congruent to triangle CDB by side, angle, side. Proof B, I'm just going to write bisect up here. It's a huge hint. It tells us we're going to use that. And then RQ is congruent to SQ is our given. Well, I'm going to look at that bisect. QP bisects angle RQS. So RQS right here is bisected. And I'm going to put an angle 1 and an angle 2. Angle 1 is congruent to angle 2 by the definition of bisect. We don't have anything else in our given, so we have to look at our picture to try to figure something else out. And it's going to be right here that QP is congruent to QP by the reflexive property. And now if you look, you have side, angle, side. And you can say triangle RQP is congruent to triangle SQP by side, angle, side. Letter C, PN bisects. So I'm going to write bisect in our given. And then MP is congruent to OP. We always start with that given. So MP is congruent to OP. And this bisect statement tells us PN bisects MO. Well, that means those pieces will be congruent. MN is congruent to NO by the definition of bisect. Now we have 2 sides congruent to 2 sides. We need to look at something else. Look at our picture to see if there's anything else we can come up with. And we can say that NP is congruent to NP by the reflexive property. And now we have 3 sides in this triangle, congruent to 3 sides in this triangle. And you have triangle MNP congruent to triangle ONP by side, side, side. Couple more proofs on the next page. Next one, JL bisects an angle. It's an angle that's being bisected. And then angle K is congruent to angle M is our given. So right here, K is congruent to M. And I'm going to look at this bisect. KLM is the angle that's bisected. So I'm going to write a 1 and a 2 in there. And I'm going to say angle 1 is congruent to angle 2. And that's by the definition of bisect or angle bisector. So those two angles are equal. We don't have any other hints in the given, so we need to look at our picture. And sure enough, the bottom of the triangle, bottom of that triangle, is same piece as the top of that triangle. So we can say JL is congruent to JL by the reflexive property. And then we can say triangle JKL is congruent to triangle JML. And right here are the two things we do not know. So you can start on either side of those with your sides and angles. And you can either have side angle angle or angle angle side. And it doesn't matter which way you write it, and you really only have to write it one way. Letter E, you have K is the midpoint of two different things. You'll notice there are two segments here. So K is the midpoint of HL. That tells us LK is congruent to KH. And K is the midpoint of MJ. So MK is congruent to KJ. That is by the definition of midpoint. And we probably should mark up our picture. Those two are congruent. These two are congruent. We don't have anything else in our given, so we need to try to figure out anything from that picture that would be congruent. And that's going to be these angles here. I'm going to put a 1 and a 2. Angle 1 is congruent to angle 2 by the vertical angle theorem. And now we can say our triangles are congruent. And write down what you think you will get for your sides and angles. And this one will be side, angle, side. Proof number F, we are given AC is congruent to BD, and then we have two right angles as our given. So here's some right angles, and those two are equal. Really not a lot we can work with in our given. We can say that those two are equal. BC is congruent to BC by the reflexive property. Since we have a right angle here, we can say that the two triangles, triangle ABC and triangle DCB, are right triangles. That's by the definition of right triangle. And now, since we know those are right triangles, we can say triangle ABC is congruent to triangle DCB, and that is by hypotenuse leg. Since we have a right triangle, we know we have a hypotenuse. Hypotenuse is equal to the hypotenuse, and the leg is equal to the leg. And we have one more proof at the top of the next page. We have a midpoint, which is a nice hint for us. And then BAC is congruent to DEC. And that is our given. Since we have midpoint, let's use that. C is the midpoint of AE. So we can say AC is congruent to CE by the definition of midpoint. We don't have anything else in our given, so we need to look at our picture and see if there's any way we can figure out any angles or sides are equal. And we can say right here, angle 1 is congruent to angle 2 by the vertical angle theorem. And then you can say triangle ABC is congruent to triangle EDC. And write down what combination of sides and angles you think we have. And this one will be angle, side, angle.